Okay, let's get started. There's several things I want to do today. One is there might be questions about the assignment. So we'll start with that. And then I want to spend a little time talking about the room. Besides having power outlets for everyone, there's some other features of the room that some of you may not be aware of. And then no, there's no espresso machine that comes down from the ceiling and, right. So let's start. Are there any questions?
Number 8. How we find text? I couldn't really find a straightforward way. Everything that
So what was problem 8?
That was the one where we create file containing randomly generated.
So the question is, on problem 8, how are we going to create the file?
How do you they're all randomly generated? For file handling.
So yeah, for handling the files in Scala, you have to fall back to Java, right? And the textbook has a chapter on file I/O, and they show you how to write files and read files, right? And so then the question is, how do you find the average and how do you find the median, right?
Maybe prefacing that. So do you want us to, then do you think that would be the best way, but if it is, we have
Well, the course is called Big Data, and 10 million numbers is not really big. Have you tried it? And how long does it take? What machine are you using? Yeah, so one question is, how can we deal with that large data set?
like, are you going to store 10 million values?
Well, so the one question is, how large of data can you sort in reasonable length of time? Has anyone tried sorting in Scala? Nobody?
Are we supposed to be sorting text? You read the problem, it's like, we're supposed to arrange it, then we're, sort them, because I feel like if you're sorting, it's kind of cheating almost, because you're sorting text off. I don't know if the left.
So one comment was, it doesn't seem fair to generate a random array, sort it, and write the file, right? That's correct. Yeah, the goal is you have a file with numbers and you want to find the average and the median, right? So I'm going to postpone talking about this question for a few minutes, and when we go to talk about the room, we'll then come back to it, okay? Any other questions? No questions? Well, actually, I have a question for you. Is that a big error? 0.1? Yeah, what's the context, right? If we're talking about a number that's supposed to be right, if we're talking that range, then that's a very small error rate, right? But if our number is big, right? So how do we capture that when we talk about errors? The difference between what? Yeah, so that's this number, right? The difference between what it should be and what I got, right? But if what I should have got was this, and instead I got 0.1, no big deal, right? But if what I should have gotten this, but instead I got 0.3, both of these, right, give us the same error. So reporting this as an error really doesn't tell us what's going on, right? Anyone take numerical analysis? Everyone avoid numerical analysis? People are too shy to say anything, except people in this table. Well, yeah, so basically, actual value minus expected value, take the absolute value, right? And then the expected value, right? And when you do that, in that case, it's going to be large, right? and in this case, it's going to be very small. Yeah, so how do you know the expected value, right?
We were at exploding point, and we had something that an actual calculator, and then it should be. We had code the certain bits that lost code. We have a different value.
So the response was, did everyone hear that? Basically, you're doing a calculator to get what expected value, and then doing a code. How do you think the calculator computes the value? Your software is better than the software, the chip in your, the processor on your. Yeah, in the context of the assignment, you know what the expected value is, right? Because the math is simple, right? In reality, it gets more complicated, because how do you know what it's supposed to be, right? So it does become more complicated, but this is sort of what we want to deal with, because it tells us not just the absolute magnitude, but relative to what we're dealing with. Now, if you take numerical analysis, right, they will then you'll spend the whole semester cranking through various algorithms and say, look, if you do it this way, here's what you get, here's the error to accumulate, and then we try doing getting error rates. Right, so here I'm just getting you started and thinking about, well, what am I trying to do with all this? A couple of problems are pretty simple, right? Add these two numbers together, what do you get? What should it be? What's the point of doing that? Well, in the assignment, right, I had a couple of problems which are like, add these numbers together, what do you get? What should you get? What's the error rate? What's the point of that question?
Is it help us see the expected value? When we have larger data sets and we have a bunch of data maybe that we don't fully comprehend yet, we might not see the actual error.
Yeah, that and also, how many people worry about floating point precision? Right. Yeah, when we're crunching numbers, you have to worry about these things, right? Because they could come into play. And we'll talk, a little bit about a few things we can do to improve the situation. But if you're not using any floating point values, you sort of forget that there's imprecision here, right? And there are some common problems. There's a big number, add a small number goes away, right? Other questions? So the question is, how much effort did you try and make this look like Scala, right? The Scala code. Well, at this point, that's going to be hard because you haven't dealt with closures yet and anomalous functions and things like that. So I don't worry too much about that part. I do worry about different languages have different naming conventions, and that's something I would expect computer science graduate students to realize, oh, I'm in C# now, and C# method names always start with a capital letter. I'm in Java now, function names always start with a lowercase letter, right? That's just the way, different languages have different naming conventions. That's pretty obvious, right? You just start looking at the code, look at the textbook, you see what style they use. In terms of being, a Scala expert and just, writing those 3 lines that look really slick, I don't expect that. Any other questions? Does everyone know how to measure how long it takes a piece of code to run? What's that? Yeah. Yeah, time before and time after, right. Yeah, you have to work, Scala does borrow lots of things from Java, right? Because it sits on top of the JVM. So if you know how to do it in Java, you know how to do it in Scala. Any other questions? So let's talk about this room. Oh yes, each table has their own monitor. And of course there's 2 tables in the middle of the room, and so the monitor is a fancy elevator, right? Also, each table has its own computer. There's a PC and a Mac. How many people have been in a room like this before on campus? So a few people, right? So each table can run a PC or a Mac, right? Let's see, and there should be a control. There's a button, right,